by the way, this video is going to talk you through the solutions to the practice papers for National 5. These are available from national5maths.co.uk. That leaves me, so this is paper A, paper 1. So question 1 is a fraction. It asks us to work this out. Now, there's two different ways to do fractions. Some people always make them top heavy first. Other people might want to just subtract the whole numbers. I'm going to subtract the whole numbers and just deal with smaller numbers. So I'm going to do 3 take away the big 1, leaves me with a big 2. And that leaves me with 2/5 take away 3/4. I do smile and kiss. So we kiss first, and that makes the denominators 20. And then we start from the top left, cross multiply. 2 times 4 is 8, and 5 times 3 is 15. Now that leaves us 2 and 8 20ths take away 15 20ths. Obviously the 8's a bit too small to take away 15, so what is 8 take away 15? It's -7 with 2, and I've still to take away 7 20ths. Now 2 take away 7 20ths means I'm going to have to take some away from the one whole number. So that's a bit like having 1 and 20 20ths. Take away 7 20ths, which is 1 and 13 20ths. Now some people will go straight from there to there and get that answer. You could also leave it as 33/20 for full marks as well. Okay, so again, that last step, there's lots of different ways to go. To factorise this one, we're going to put it into 2 brackets. X goes in the front of each bracket because x times x will give you the x squared. On the outside, we're looking for numbers that multiply to 15 and add to +2. So it's some combination of 3 and 5. To get +2, it's got to be 5 take away 3, so plus with the 5, take away with the 3. And again, you might have those brackets the other way around, as long as the minus is with the 3 and the plus is with the 5. Question 3 wants the equation of the straight line. So to get the equation of a straight line, first thing I would do is write down a couple of coordinates. So I'm going to use this coordinate here, which is 0, 5. And then I'm going to go along the line until I find another nice one that's easy to read off. And I'm thinking, there's not hugely many, but every single one is going to be going up 10. So this one could be 115, 225, 335. I could choose any of these coordinates, to be fair, to get my gradient of the line. I'm going to just go pick a random one. I'm going to take the 335 one. So gradient is y2 minus y1, so that one, take away that one, is 35 minus 5, all over 3 minus 0, which gives me 30/3, which is just 10. So my gradient is 10. Now there's 2 different ways to go from here. We could use y equals mx plus c. So I'm going to do it both ways. So if I want to use y equals mx plus c, m is my gradient, so my gradient was 10. C is the number that goes through the y-axis, which is here, which is 5, so it's plus 5. Alternatively, you could use the y minus b equals mx minus a formula. You choose any coordinate to be your AB, so I'm going to use 0, 5 as my A and my B value. So I have got y minus 5 equals 10 bracket x minus 0, so I'm not going to even bother writing anything in there. And that also gives me, when I move it over, 10x plus 5. So that is the equation of my line. One thing I would tell you to do if you're going to use this middle method, where I've done it in green, I encourage you to always write down your c equals 5 value first of all, just in case you've got the wrong y-intercept. You don't want to lose 2 marks for having the wrong y-intercept and subbing it in wrongly. Okay. Question 4 wants us to complete the square. Anytime you see anything that says write it in this form, sometimes it has p's, sometimes it has q's in there, that means you want to complete the square. So we have y equals bracket x plus, so we'll keep the plus from here, half of 8 is 4, so it's x plus 4 all squared. Then you take away whatever this number is squared, so 4 squared is 16, so we take away 16. That's to counteract the plus 16 that comes when we then square out those 2 brackets. And then we've got to take away 7 on the end. Tidy that up. It gives you x plus 4 all squared minus 23. And that is it in completed the square form. If you're asked to find the turning point is literally using these numbers here. The turning point is using the 4 and the 23. Your turning point is always BC. Now, is the opposite of what's in the bracket. Plus 4 means your turning point is at minus 4 and then minus 23. So that would be your turning point. Negative 4, negative 23. Because this equation is telling you that your graph has moved 4 to the left and 23 down. So that would be your turning point if you are doing that part. To change the subject to the formula to R, some people like to rewrite this first of all in this form and put the P over the other side. To change the subject, our aim is to get this capital R on its own. So we need to deal with 3 things. So we need to deal with the cubed, the B and the 5. Always deal with the thing that's not attached first, which is a minus 5. The opposite of taking away 5 is adding 5. So that becomes P plus 5 on the right hand side. Now we need to deal with the B. B is multiplying R cubed, so the opposite of multiplying is dividing. So we divide the right hand side by B. And then the last thing is to deal with the cubed, and the opposite of cubing a number is taking the square root. And just watch, your square root looks like it is going over absolutely everything on the right hand side. So final answer is a cube root of P plus 5 all over B. Alright, and that square root has looked like it's going over the full fraction and not just the top line. Question 6, about some vectors. We have to find u plus 3v. So we have 2 minus 5. What that means is we have to multiply this whole vector by 3. So I'm just going to do that in one go. So we have to take the vector u and we have to add on negative 12 and 9. So that's what I've got from multiplying v by 3. And then it's just add the top lines. 2 take away 12 is minus 10. People make really silly mistakes here with their integers. And minus 5 add 9 takes you to positive 4. So that is part A. Part B wants the magnitude of that. So the magnitude is when you take the square root of each of your numbers squared. So it's the square root of minus 10 squared plus 4 squared, which is the square root of 100 plus 16, which is just the square root of 116. And I would leave it like that. It's non-calculator. They've not mentioned having to simplify it using surds at all. So I would be quite happy with that answer there. If you wanted to do it using surds, you could use root 4 and 26. And then that would give you 2 root 26. But as I said, I think root 16 would be perfectly acceptable here for a final answer. Question 7 says this is a graph of cos bx. State the value of b. Now your cos graph should finish at 360. So this number here is 360. But they've got this graph finishing at 120. That means we can fit 3 of those graphs in, because 120 into 360 is 3. So b is 3. And you can either just write b equals 3, or you can just write the equation again, that is the graph of cos 3x. Whichever way you write that, you'll get the full marks for that one. Okay. Question 8, point of intersection. Anytime I see the point of intersection, it's asking you to do simultaneous equations. So I'm just going to rewrite this one underneath that one. Right, simultaneous equations. I always teach to get the middle to the same 1 plus 1 minus. So I've already got 1 plus 1 minus, but I need to times the top one through by 3. So my equations are going to become 6x plus 3y equals 15. And x minus 3y equals 6. At that point, I can just add them together vertically now. 6x add x is 7x. 3 and minus 3y cancel out. 15 add 6 is 21. 7 goes lovely into 21. If it doesn't divide nicely, go back and check that you've got your equations started off correctly. So x is 3. Once you know what x is, you can sub it back into one of your equations. I'm going to put it back into the first equation just because there's no negatives there. So you have 2 times 3 plus y equals 5. 6 plus y equals 5. Positive 6 will go over and become minus 6. So you've got 5 minus 6, which is minus 1. Now it asked for point of intersection. So the point would be xy as a coordinate. So 3 minus 1. Now the beauty with simultaneous equations is you can always check. I never used the second equation, so I'm going to check in that one. X is a number 3, so that would be 3. Take away 3 times minus 1 equals 6. So I need to check this gives me 6. So that really gives me 3. Double negative makes 3 plus 3, which equals 6. So I know I've got the right answer. The coordinate was 3, negative 1. If you don't write it as a point, you will not get full marks because the question wanted it as a point. Okay, we have to determine the nature of the roots using the discriminant. So they don't always tell you about the discriminant. Sometimes it just says determine the nature of the roots. Whenever you see that, you have to use the b squared minus 4ac. And whatever number comes out will tell us what the roots are. So remember, a is the bit there, b is the middle term, and c is the end term. So a is 1, b is negative 3. Remember, whatever sign is there goes with it. So negative 3, and c is 7. So b squared is minus 3 squared. So I'm going to go straight to saying that's 9, positive 9. Take away 4 times 1 times 7. So that gives me 9 take away 28, which is negative 19. So because my discriminant, so because b squared minus 4ac was less than 0, there are no real roots. No real roots. So that means that this smiley face quadratic here doesn't have any roots at all. So it maybe sits like that, floating somewhere above the x-axis. Okay, we've got a straight line. The second line is parallel to this and goes through another coordinate. Anytime we talk about parallel lines, it means it's got the same gradient. So we have to find the gradient of this line. Now at the moment you can't find the gradient because it's not in the form y equals. Now the first thing I'm going to do is I'm going to move the y over because I don't like a negative in front of my letter. So I'm going to make that 3x equals y plus 9. Then I'm going to take away the 9. So I have got 3x take away 9 equals y. Now the number in front of the x is your gradient. So I know the gradient of my new line is 3. And I know the point is 5 minus 3. So just to reiterate, the gradient of both lines is the same because they're parallel. For this one, I don't know the y-intercept, so I'm going to use y minus b. So I've got y minus 3 when I plug in there because this is my a and b value. So it's y plus 3 equals 3 bracket x minus 5. So y plus 3 equals 3x minus 15 when you expand the bracket. Take that 3 over, it becomes a takeaway, so minus 15 minus another 3 is minus 18. So that is the equation of the second line. Question 11 is quadratics. So we've got the picture, we have got the equation here, and we're asked several things about it. So it wants the coordinates of the turning point. So the coordinate is always BC. And it's the opposite of what's in here. So minus 2, you do the opposite, that becomes positive 2. So the coordinate is 2 and then minus 9. And if you look at your picture, that works, doesn't it? 2, negative 9. So this bit down here is your turning point, and that's 2, negative 9. The coordinate of C lies on your y-axis, so it is 0 something. X is 0 in this case. Remember, the first part of your coordinate is x. So I'm going to plug in x as 0. So I've got y equals 0 take away 2, just gives me minus 2 all squared minus 9, which gives me 4 minus 9, which is 5. So the y coordinate is, is minus 5. Gives you 0 minus 5, which again matches the picture. So that is minus 5. And we said that was 2, negative 9. It then tells you A is a point negative 1, so I'm going to put a negative 1 here. And it says state the coordinates of B. So when it says state, it means there's not really any working. Now, if the middle of this graph is at number 2, we can do this without actually doing anything. Minus 1 plus 3 is 2. Plus 3 will give you the coordinate of B again. Just using symmetry because this is right down the middle. So 2 plus 3 is 5. So B is coordinate 5, 0. Okay. Getting towards the end now. So we're told the square and the rectangle below have the same perimeter. So the perimeter is when you add up all the sides. And it says show that the length of the rectangle is given by 3x plus 1. Right, so perimeter would have been, so the square had a perimeter of 4 of these. 2x plus 2, 2x plus 2 and so on. I'm just going to write that as 4 lots of 2x plus 2, which gives me 8x plus 8. So that is the perimeter of the square. The rectangle has 2 of these ones, so 2 of the x plus 3's, so that's that side and that side, and then it's got 2 of the lengths, so I'm just going to call that 2 capital L. Now that gives me 2x plus 6 plus 2L, and that is for them. Now we're told that they have equal perimeter, this bit up here, the same perimeter, so I'm going to put these two things equal to each other. So 2x plus 8 is the same as 2x plus 6 plus 2L. Now if I move everything to the left hand side, I'm going to have 8x take away 2x is 6x. I'm going to have plus 8, that will become negative 6. 8 take away 6 will give me 2. So I've got 6x plus 2 equals 2L. So L will be each of those numbers halved, which is 3x plus 1 as required. So that's what I like about proof questions. I can then see that I've got the right answer. So the length is 3x plus 1. Okay, and the last 2 questions, we have fractions and surds. So I'm going to do the fraction one first. Now, my class do smile and kiss with these bits. So if we do the kiss first of all, that gives us a denominator of x bracket x plus 2. Now for the smile bit, we do 3 times that. So we do 3 bracket x plus 2. There was a minus sign in between. And then we multiply those two, so take away 5x. And then we tidy out the top line. So that's 3x plus 6 minus 5x. All over x bracket x plus 2. There's no point multiplying that out. You can if you want, but you could make a mistake. And then tidy up the top line. 3 take away 5 is negative 2. So we've got negative 2x plus 6 all over x bracket x plus 2. That's the answer to that one. Part B is surds in simplest form. Here is our clue. The fact that there's already a root 2 in there means I think 2 goes into all the other numbers. So 2 into 18 is 9. So we've got root 9 times root 2. Take away root 2 plus 2 into 72 is 36, which is your square number. Temptation is to use 8 and 9, but that's not going to allow you to tidy them all up. So 2 goes into all of them. Square root of 9 is 3, so we end up with 3 root 2. Take away root 2, and the square root of 36 is 6. Now remember, there's a secret number 1 in front of that middle one, so really what you've got is you've got 3 take away 1 plus 6, which is 8. So we're left with 8 root 2 for your final answer. Okay, thank you.